Welcome to clickmyproject.com. Let we discuss about the process kernel-based learning from both qualitative and quantitative labels application to prostate cancer diagnosis based on multiparametric MR imaging. Let me see the abstract of the process. Screening and early detection of abnormalities needs an automated system that identifies the abnormalities and cancers in MRI images as early as possible. An automated system that segments the abnormalities and identifies the defects in MRI images is proposed. The cancer in the MRI images were identified by manual labeling of the tumor portions in the images. The tumor portion in the images were identified, and also the state of the tumor is also identified. The method identification of tumor is based on manual labeling of the tumor portions. The tumor portions were recognized with the help of identification of the feature points in the images using a mean value calculation. The images were divided into small patches. The patch separation process takes place by identifying the seed point around the images. The image pixels around the identified seed points were taken. The features were extracted from the images by calculating statistical informations from the images such as mean and standard deviation. The statistical based informations were much helpful to identify the portions in the images uniquely. The texture based informations were also needed to identify the tumorous portions more clearly. Gabor filters proposes the optimization localization properties in both spatial and frequency domain. The impulse response of these filters is created by multiplying an Gaussian envelope function with a complex oscillation. The phase difference of the left and the right filter responses to the estimate the disparity in the stereo images. The identified patches around the seed points were then classified into benign stage or malignant stage. The stage of the tumor is identified using SVM classifier. Different types of SVM such as PSVM and FSSVM were implemented, and the performances of the methods were compared with different methodologies using accuracy, sensitivity and specificity. The classification process employed using SVM produces better results compared to the other segmentation methods, and the process is capable of identification of different types of tumors differently. The different type of tumors were identified and they were denoted in separate manner. Let us see the flow of the process. This process is based on the segmentation of the needed portions from the images based on classification methodologies. Here the input MRI images were obtained. Here we have used the MRI of breast region. The obtained images were pre-processed with help of filters. The filters refers to the in overall the overall intensities in the images were normalized to a particular range in the pre-processing process. After that, the tumor pixel labeling is employed. The tumor pixel labeling refers to the selection of the needed pixels from the regions. Needed pixels refers to the tumorous portions that we have obtained. So the tumorous pixels were selected with the help of the thresholding operations, and the labeled regions were selected. After that, the features were extracted from the regions based on statistical feature extraction. The statistical feature extraction, we calculate the overall mean and standard deviation, and based on that the values were saved as features. The extracted features were then used for the segmentation of the regions into normal, benign and malignant, which is based on SVM classification. The extracted features were classified with the help of support vector machines into three different regions. The identification of the different types of tumors will help in the notifications of the different portions in the images. Thus, the SVM classifies the images into normal, benign, and malignant. After that, the segment benign and the malignant tumors were represented in different representations, and based on that, the segmentation is done. After this, the overall performances of the process is measured. The overall performances of the process is measured in terms of accuracy, sensitivity, and specificity. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface to run the program. So select any one of the images by clicking this, or else we can select them by browsing through this. After that, we apply any one of the filtering processes. The filtered images were displayed here. After that, the tumors were labeled by means of the identification of the tumorous pixels based on the thresholding operation. After that, the features were extracted in terms of the calculation of the mean value. So the pixel locations were identified. The overall mean values of the identified regions is got. So here the zero elements were eliminated and the regions were only accepted. So this is the eliminated portion from the image, and this is the selected portion from the image. So thus we have selected the tumorous portions in the particular locations. Then after that, after eliminating the zeros, we get the mean value results like this. After that, we employ the seed point selection processes. So we select the particular seed points from the images in order to say classify those regions as tumorous or non-tumorous. So like that, we select the particular regions. Then after that, the segmentation process is employed, and in the segmentation process the different regions were obtained. So the red color, if the regions were segmented in red color, means they indicate the malignant tumor, and the green indicates the benign stage tumors. So these labels were assigned, and based on that the contours were extracted. This is the normal portion and this is the tumorous portions that we have got. The overall performances of the process is measured in terms of accuracy, precision, and recall, which is in otherwise called as sensitivity and specificity. So thus we have calculated the regions in the images that contains benign and the malignant tumorous portions, and we have segmented them with different color representation. The tumorous portions were identified in the input images based on the segmentation process, which is done using support vector machine classification, and the features were extracted based on the statistical parameters mean and the tumorous regions. For selecting the tumorous regions, the shift based descriptors were employed for the selection of seed points all around the images. Thank you.